So it's the don't care condition. What is the meaning of don't care condition? We don't care that the number is 0 or the number is 1. We don't care. So in this place we write the cross. Okay, so let's take an example for that. 1 0 0 1, and this one be 1 x 0 0, and then let's take x x 1 1, and finally we have 1 0 0, and let's take 1. Okay, so what is it? It is Carnot map 4 into 4, as I have mentioned up here. Okay, you get that already. You are getting smarter, my dear friend. Okay, so we have this thing, distinctly distributed thing. So x is representing that it can either be 0 or it can be 1. We don't care about that. So we can include that in our ring to expand our area. We have practiced so much of soft form, so let's practice the pause form. Means we are working on 0 or 1. Give me the quick answer on this one. 0 or 1, 0 or 1, 0 or 1. Yes, it's 0. Correct, my dear friend, because this is SOP form. Excellent, my dear friend. Okay, now let's say it is something ABCD type. Okay, this is 0 0 0 1 1 1 1 0. Great code, right? 0 0 0 1 1 1 1 0. Only one bit change. Very code. Remember? Very good. Now it's time to make or couple of the things. So as we are taking the zeros, so which kind of the zero is most preferable? Well, if I take these two, well, remember I am opening it up because these two are also waiting, and the cyclic form will complete the 4 pair, which is better. And in this case we have this one. So this is our group 1, and let's call it group 2. So we can expand our cycle, and by expanding our cycle we can easily calculate the things, which is fantastic. And now we can solve this. So let's complete the question and simplify it. Well, I have not written the question because I made the Carnot map itself. So let's do it. It becomes our responsibility to do it. So A, B, bar, bar. This will gonna be A, B, in which we have the bar on A. This will gonna be AB, and finally this will gonna be A, B, bar. Okay, this is gonna be C, D, bar, bar. This will gonna be C bar D. The next one gonna be C, D, and finally we have C, D, bar. Excellent. Now, what is remaining the same? Remember the trick? We are doing the trick things. We are not going to write everything again and again. We are going to use our trick. So the trick is these two and these two. The group 1 thing. We are talking about the group 1. So what we need to write in the group 1? What remained the same? Excellent. What remained the same? B bar did not remain the same, right? B bar remained the same. So B bar remained the same. And what else? As you can see, these did not change. Means D did not change. So the answer for this one is B bar D. And now it's time to write the group 2. So let's write the group 2. We have a sign of addition as usual. So in the group 2, we have what did not change? So B did not change, right? So our group 2 is having B. This one is for the group 1 that we have simplified. Group 2 is B did not change. Okay, what else did not change? Yes, C did not change. So B and C. This is our final answer. Well, if you understand this trick, you can do most complicated Karnaugh maps quite easily. So, learning a trick is not bad. Just remember the key word for this trick is take the same. Take same and leave different. So, we leave the different thing and take the same thing. That's all it. So we have learned this in a quite fantastic way. So congratulations, my dear friend, you have learned the don't care condition. And you also learned the application of Carnot map in the 4-bit. Now I am having a question for you. What are the limitations of Carnot map? Well, everything in the science or technology is having a limitation. So we have to define that. The accuracy of Carnot map for reducing Boolean algebra is limited to 6 variables only. It means we have up to this thing A, B, C, D, E, F. After this point, if we try to apply the Carnot map and try to do the things, it will going to give us the wrong results. So we cannot use it for forever. We can use it up to 6-bit or 6 variables. Well, 6-bit is not small in that case either. It is 6, 2 to the power 6. So you have to write 2 into 2 into 2 into 2 into 2, which technically we get 64. So 64 things. It's not less anyway. Trust me. It is so much more. 64 zeros and ones combination. It is used in all the basic devices that you are seeing around you, like a simple torch if you design, or the let's say traffic light. Use this much. That's it. So it is widely used. Yeah, we are having a tremendous amount of the development. So we have other things too. So to solve that level of the simplification, we require something new, which is known as prime implicant. So what is the prime implicant? Well, the nature of the prime implicant is such that we make the table itself. So it works till any amount of the variable. Quite easily, we can solve it all the things and all the way. So this is all about the Carnot map application, and we are finished with the limitations even. So we are going to see the prime implicant in our last lesson for this section. So stick with me, stay tuned, and God bless.